Hey now, this video is about ionic bonding. So, ionic bonding is the transfer of electrons from one atom to another to achieve a noble gas composition, which is having a full outer electron shell, ultimately forming ions because the positive charges inside the nucleus and the negative charges of electrons outside are not balanced out anymore. And the ions produced are of opposite charges, and unlike charges they attract each other and causes them to be held together with a very strong force. So in other words, we can say that the ionic bonds are the electrostatic attractive forces between the positive and the negative ions. Now, a very important point to remember is that ionic bonds are formed only between metallic and non-metallic ions. So here the ions are formed when electrons are transferred from a metal atom to a nonmetal atom. The metal atom loses electrons from its last shell to become a positive ion, also called the cation, and the nonmetal atom gains electrons into its last shell to become a negative ion, also known as the anion. Okay, so let's work with an example here. Sodium reacts with chlorine to form sodium chloride, which is a table salt. So in this reaction, sodium atom loses an electron by transferring that electron to the chlorine atom. This results in the formation of the cation Na+ and the anion Cl-. Now, both the ions here have achieved the noble electronic configuration, and the opposite charges that they've acquired attract each other and formed a very strong ionic bond of NaCl. So the way we have drawn our compound here is called the dot and cross diagram, and this is usually how you're asked to draw in your CIE exams. Okay, next we need to know is the structure and properties of ionic bonds. Ionic substances have giant lattice structure in which ions are held together by electrostatic forces between oppositely charged ions that surrounds it. Now, this giant ionic structure gives rise to the following properties. Ionic compounds have high melting and boiling points because the bonds are very strong and it's a giant structure, so a large amount of heat is required to break these bonds. Ionic compounds are soluble in water, but insoluble in organic compounds. This is because the ions attract or can interact with the water molecules, which disrupts the crystal structure, causing them to separate and go into solution. Solid ionic compounds don't conduct electricity, but they do when they are in aqueous state or molten state. This is because in aqueous or molten state, the ions that conduct electricity are free to move, but in solids, these ions are fixed in place. Ionic compounds are hard crystalline solid with flat sides and regular shapes because the ions are arranged in straight rows in strong ionic bonds. The strong forces holding ionic compounds also prevent them from evaporating easily, hence they have no smell. Now, deducing the formula of ionic compounds, we can figure out the charges of elements by knowing which group it belongs to in the periodic table. Going to the right, group 1 to group 3 elements have a charge of +1 increasing to +3. Group 5 to group 7 elements have charge -3 increasing to -1. Suppose we need to deduce the formula of magnesium chloride. Now, looking at the table, we know that magnesium is from group 2 and so its ions have a charge of 2+, while chlorine is from group 7, hence its ion has a charge of -1. Now, to balance out +2, there got to be 2 -1. So a quick trick is to swap the numbers, and it's magnesium chloride MgCl2. A very important point is that the symbol for metal ions should always be first, and polyatomic ions should be placed in brackets, such as magnesium carbonate with Mg, the metal ion symbol for in the first, and then CO3 carbonate ion in brackets. Now, can you figure out the formula of aluminium chloride and aluminium oxide? No. I would really recommend you to pause the video for a while and try it on your own. So here's the answer. Aluminium is a metal from group 3, so its ions has a charge of +3, while chlorine ion has a charge of -1. So let's swap the numbers and we have AlCl3, aluminium chloride. For aluminium oxide, Al ion has a charge of +3, and oxygen is from group 6, so its ion has a charge of -2. So let's swap the numbers and we have Al2O3, aluminium oxide. The charges are completely balanced out, and if you want to check, go ahead, do the math.